Yeah, recording.
Yeah, sweet. So part one of this GIS series went through how to download some data, create a simple map, load in a WMS layer into QGIS, how to install QGIS, and a slew of other things. How to georeference a map. So if you had like a map that actually like a paper map and you wanted to put it on a GIS, you could add additional data set to it. We went through all of that. So today, the main focus is going to be hydrological analysis to identify delines and the process for doing that. So here, just for everyone else's benefit, this is the New South Wales topo map. To get access to that map, essentially you just search maps, WMTS topo. Get the link here, copy that, go to QGIS, go to layer, add WMTS layer. I'm going to create a new one here, call this maps topo. Drop the URL in. Okay, connect. That'll open this up, and I can just add the topo layer there. Let's just come in right there. So I'm just going to remove this new URL added. So today we are going to create a work out how to identify delines. So firstly, last time we went through and downloaded a series of 2-meter resolution terrain tiles. These are available via Elvis. So in case it's there, it's available for all of Australia. The New South Wales stuff is particularly good. And a lot of the Queensland stuff's probably also okay. New Zealand, if you're there, I know Alan, you're on the line, but the New Zealand equivalent is called LINS. And their data is even better. Like it's really good. So if you're looking to do this stuff in, you just sign up and kind of go through it. I can, if you keen, I can show you how to do all the sign up stuff. It doesn't take much effort, but the data is, in short, very good. So you'll download it. There's a series of tiles, geotiffs, so on and so forth. I've downloaded those here. They're all just saved as, in this case, the ASC files. Don't have to know too much about what they are, except for their rasters. And then I've read them all in and converted them to a virtual raster. A lot of that was covered in the last talk. So now our next question is, how do we identify delines, especially when you've got a big area? Deline, and when you're actually there, like to save you bush bashing through kilometers of dirt, you can kind of let the computer do a lot of the work for you. And because most of this stuff is picked up from LiDAR as opposed to photogrammetry, the LiDAR points generally get through the foliage, so you can actually get like ground value. So once I've read this in, I've got this read in, and I'm just viewing it as a hillshade. So I've just got, so if you were to just look at it as color, they're not as useful. It's not very good. So I'm just going to change to hillshade there. I think I can also, this new version also allows us to do it as contours, which seems pretty neat. Oh, I haven't tried that. Oh, that's pretty cool. But I don't want that. I want hillshade. So if you go with hillshade, you can already start to see, some of the really big dolines. I think that's playing fields there. There's Edmonds Folly, and there's a few others. So how do we identify dolines? So one of the key, the US Army has spent an awful lot of money over the years developing tools for doing hydrological analysis through the US Army Corps of Engineers, who are responsible for doing all sorts of waterway projects in the US. So one of the tools they created was this thing called GRASS. And one of the features of that, to build a flood model, you need to make sure you have a digital elevation model that doesn't have any holes in it. Because if you have holes in your digital elevation model, your flood model generally just breaks, because you just have these like places where water disappears. So one of the first things you generally have to do is fill in all the holes, which is really useful. So I'm going to write, I remove a whole bunch of this stuff. I'm going to run a process to go and fill all these holes. And then if I take the new layer, which has all of these holes filled, and minus the old layer, which didn't have those holes filled, I'll be able to work out where all the depressions are in the land. So here's the elevation. So I'm just going to create this depressionless DEM. DEM stands for digital elevation model. And it'll just go through and create some, create this DEM for me. It takes a little while to compute. And you should be able to run this on most computers without too much effort. It takes a bit of computing power, but generally it'll process through. The like this stuff was made, when this stuff was made, it was all written in Fortran and really the old school pieces of hardware, so it's fairly well optimized. So here's this depressionless digital elevation. I'm just going to convert it to hillshade so you can kind of see what happens. And you can see where a lot of like the holes have disappeared. Things that would have caused issues with the flow path. So, for example, oh, there you go. Like playing fields down has just disappeared. It's all gone. So if we take this depressionless stem and minus it from our original DEM, we'll be able to identify those pixels where there's a change has occurred. So to do that, you go to raster calculator. I'm going to go to, say, Janelle DEM minus depressionless DEM. And the depressionless DEM actually should be higher. So I'm going to depressionless DEM. It's greater than, let's go 0.2. Right, so that should be okay. And that should give us all the points where we have these, maybe even 0.0. So I'm going to call this, I'm going to save it at a yeah, a key thing to note, this is there's a greater than sign there, so this will return a binary value of 0 if it's false and 1 if it's true. So all the areas where it works should end up as a 1. All the dolins should be 1. All the major dolins at least actually should be 1s. And you could fiddle with that a little bit as well. There's a fair bit of room to move that around. Oh, okay, there we go. So there's the DEM diff. That's run through. These are also of interest. These problem areas, and they're places where the algorithm kind of just went, nope, this doesn't work, or didn't work well. So yeah, and those can be quite useful as well, just to have a bit of a look at. Some of them are just byproducts of the nature of their elevation model, but they're also quite useful to look at. But now if you move on to this, I'm just going to change some of this around and move this to go unique palette of values, classify. I'm going to remove that one, apply, get left with all the reds. I can go to transparency, increase it. Then we are now doing pretty well. Okay. Now I've got all these areas. I'll zoom out a bit. So these are all the places that look like potential domains, or at least they're depressions in the digital elevation model. And now you can start to look through them. Let's see how we did. So just to like verify, let's go check some common, well-known large domains. There we go. Oh, wait, where are we? Those playing fields. Oh, yeah. Playing field should be around here somewhere. Go back to the like that. I'm in the wrong part of the valley. Oh, there you go. There's playing fields. All right. So, and then you can have a bit of a play, have a look around, see what you found. And next, you can start to, I guess, identify targets, sort of clean out all the noise, or look for things that are interesting. So that's pretty interesting. Another good one I also quite like looking at is what's out here. See if there's anything in the southern limestone. Oh, I think that's bloodsucker. Out here. Yeah, that's bloodsucker right there. And like you can see how obvious that is with the digital elevation model, but if you're looking at imagery, that sort of thing is like next to impossible to pick up, right? It's just very hard to see, but they show up really clearly on a digital elevation model. You kind of use these together to build up the picture of what you're looking at. That actually covers the vast majority of what I wanted to talk about. If anyone's got any questions, otherwise I can, if you want to go through some of the process for cleaning up a lot of these small stuff, what you can do is projection miscellaneous version. You can convert a lot of these rasters to vectors. So I'm going to convert these div to vectors. And this will create a series of polygons essentially for items that are close to each other. This might actually take a little while. Oops. Right. So go and we can see how it's sort of assigned to these little IDs. I'm going to get rid of. I'm going to do. They've got these kind of IDs that have been assigned to each of them. If I click that, there it'll tell me about these particular ones. This is DN number 0. That's not really interesting, so we'll get rid of that. And we're going to make a few other changes here. So let's go here. I'm going to create a field calculator. I'm going to add in, right, should be able to add area, should be one of these. Geometry, area, Philly, yeah. That'll do. I'll call it area. All numbers fine. Let's give it 10. Apply. There's probably at least one here. So this is the one that we want to get rid of. And I might just go, now that I've added that, I might go here. And I might want to filter. Properties. B. Filter. Area. Greater than. Let's go with 5. Select features or maybe not select features. Actually, just selected all of them. I'm just going to delete one of these. Also, just delete these. Edit. Delete that. Okay. Now I've gotten rid of that main one, which is handy. I'll save that. And these are all the other polygons, and we've got areas that are associated with all of them. Oops, sorry. I had a whole lot selected there when I deleted those, actually. Probably shouldn't have done that. That was a bad idea. So I don't know if there's an undo button that lets me undelete all of those. Oops, I've made a mistake. I've deleted everything I wanted. So I have to read that again. So, analysis. Does anyone have any questions? Please just chime in whenever it feels pretty strange, kind of talking to a computer. So please feel free to chime in whenever if you feel. There's a select features button there, which is kind of in the spotlight. Oh, here we go. That's the one I want.
I think Alan's got a question in the chat. Do you want me to ask it?
Oh yeah.
He said, no, he doesn't have a question. He just said this would be awesome for the Nullarbor.
Yeah. So something like the Nullarbor would be great, right? Because you'd be able to pick up all of these domains pretty easily, and the area is really big. And the good thing is, if you're willing, Alan, do you guys they still do those to these days? You could do it on a drone flyover, right? And because there aren't any trees, it's in the name. You can go and collect all of this data just by flying a drone over the landscape, and then do analysis on all of these afterwards. And there's already software that's available for doing all of that. And that's pretty cheap to do because all you need is a drone and a camera to do the photogrammetry on it. Because you capture the same thing from multiple angles and you'll get that. And because you don't have trees, you don't have to have lasers that cut through stuff. It'll just pick up.
He says there are some trees.
Okay. Right. Well, I guess the name was misleading. But then if you go through and do that, you can pick all of that. Although I presume the South Australian government probably already has some data. If your domains are really big, you don't need stuff at such a high resolution. So if you've got like, so for example, if your domain is bigger than 30 meters wide, you'll be able to pick that up just from the shuttle radar missions. And that stuff's available for everywhere on the planet. It just goes through and you'll get the entire planet from that. So if you've got really big domains, you can just pick it up. You don't even need like government supply data. You can just get the and that works anywhere in the world. So even if you're in Papua New Guinea and the domains are really big, you'll be able to find those. So here's like kind of a example of some of the outputs. Now, if I go here and I'm going to save the layer edits now that I've done it correctly, I'm going to stop editing. I only want to say I'm going to add a field. I'm going to edit mode, open attribute table. I don't like this version. What did I just do? Here we go. That's the version I would prefer. Open field calculator, create a new field. I'm going to call this field geometry, and I'm going to call it area. Okay. Put field name and call it area. And it's going to be decimal level. Okay. Let it do its thing. Save. All right, we're done. Stop editing. Hopefully, all the areas have now come through. And say we only want to keep the really big ones. I can go to symbology or source, query builder, area, greater than. Note, we've done all of this analysis in square meters, so I'm going to make it greater than 5 square meters. Test, there's too many. I'm going to look for really big ones. Make it 10 square meters. Yep, that'll do it for now. Apply. So that got rid of a lot of the smaller stuff, and now you're kind of left with bigger holes. So those little spot differences are not picking up anymore. And although if you got one of the things where if you had like that one spot which had but there was like one depression in the middle of nowhere and there were no other depressions around it, that's probably a good sign that the lasers there have just picked up a localized hole, which could be like a small domain, which is like potentially a cave. So you could go look into that. So yeah, that goes through. And if you were if you're going to take this all the way, you might as well. I'm going to go create some centroids out of all of these. So this will go through and take the centroids of all these points. Maybe I did some additional work to refine these down. And then you can export these centroids as a, say, export says, and I might actually, you know what, I'm going to make these centroids. I only want the really big ones. Area greater than 30. Even bigger. 50. Okay. Right. So now you should only have like these bigger kind of domains in sight. And so if I was going to go head out there, I might have events and maps, in which case you can take all of this with you. But if I only had like an old school GPS, I could just save this as a GPX format and then just upload onto your GPS. Let's have far from that. Okay. And I'll export those all out. Also, there's like the stuff in here. There's a plugin that you can use where it'll automatically upload to your GPS. But because I use Avenza Maps on my phone mostly these days, I don't even need to really consider that. Oh, Alan, for you, You can also upload, save them as KML, so you can play with them in Google Maps. Doesn't actually, in this case, it doesn't even matter. Save this. Yeah, so you can then also go play with those in Google Maps if you so wish. Yeah, that's it. That's my talk. Everything else is really covered. So this I only wanted to do because it's a very cave centric. The other one's a bit more. The other one's a lot more generic, and you can use that in other stuff. But this is like no one else is doing hydrological analysis unless you're actually doing hydrology. So that's it. Any questions?
Does it pick up the does it pick up the hole in the hole in the roof of the Earl's coach house?
Good question. Let's go find out. Yes.
Yeah.
By the looks of it, it has. Yeah, most definitely. It's a giant hole.
Yeah, it's a big hole.
Yeah, it is.
Cool.
Yeah. I think it also picks up Mammoth, which would be somewhere around here. Although we might have gotten rid of it because we only looked for the small ones. Where's Adrian's Folly? Where's the big bend in the cave? It's probably Mammoth is probably about there somewhere. Although I haven't been there in so long. Somewhere. This is embarrassing. But yeah, it's somewhere around here. This region. It's where Mammoth Cave. Where's Adrian's Folly? Oh, there's Adrian's Folly. So Mammoth in that case would probably be somewhere around here. So it's probably picked that up as well. Might be it there actually. Or just actually, I don't think that's it. It's probably somewhere in there. But yeah, on the whole, or it might have been filtered out, but that probably would have been picked up in all of our filtering. Any more questions, thoughts, ideas? Alan in New Zealand, their data is a lot better, so it's probably it would probably work even better in New Zealand because their data is just nicer. They've got more of it. So they probably have more of it, but it's at a high resolution, so you can do much more detailed. So here, each pixel size that I've done here, also to save on computation power, is about 2 meters. But some of the New Zealand stuff's even finer than that. And if you're out in the Nullarbor, you can, and you flew your own drones, you can have even higher resolution. All right, gonna stop there. Questions? Otherwise, we are probably done.
Okay.
Anything in the chat?
I think, yeah.
Oh, okay. Cool. I'm gonna call it there.
Thanks,
Stop
Rafid.
sharing and all done. Thanks.